this lesson, we'll be solving quadratic functions by graphing. At the end of the lesson, you should be able to graph it and make connections between the x-intercept solutions and the zeros. So when we talk about roots, it's the solution to the quadratic equation. It is the x-intercepts, and those we write as ordered pairs. It's also called the zeros, so it's just the x values, and when we write the zeros or the roots, we put our answers in braces. When we have a double root, it means the vertex is on the x-intercept. It is the x-intercept, so there's only one answer. When there's no root, it means the vertex is above or below the x-intercept, so the solution is just an empty set. When we graph from standard form, we have to find the axis of symmetry, so we have to use the equation negative b over 2a. Then we find that, we take that solution to x, and we plug it in, we find the vertex, so we have our xy point. We put that in the middle of our table, and we use values on either side of our vertex. We draw the parabola, and then we identify our roots once we have the parabola drawn. Where does it cross the x-axis? When we're graphing from vertex form, we still need that axis of symmetry, but it's right in the equation. So we just pull out that value of h, remember, not including the minus sign. We identify then the vertex because the k is the second part of it. Again, putting the vertex in the middle, making a table, draw the parabola, and identify the roots. So in this example, we first have to find our axis of symmetry, which would be negative 8 over 2 times 1. So our axis of symmetry is 4. We plug that back in, so we put 4 squared minus 8 times 4 plus 12, and that equals negative 4. So our vertex is 4, negative 4. Then to find our y-intercept, we plug in 0, so 8 times 0 plus 12. So my y-intercept is 0, 12. To find the roots, I'm going to have to graph it. So I'll put my 4, negative 4 in the middle, and then if I plug in 2, I get 0. If I plug in 3, I get negative 3. If I plug in 5, I get negative 3. And if I plug in 6, I get 0. So I'll go ahead and graph that at 2, 0, 3, negative 3, 4, negative 4, 5, negative 3, and 6, 0. And there's my parabola. So I see that my roots are 2, 6. In braces. Next one, again, I have to find the axis of symmetry, so negative 4 over 2 times 1, and that equals 2, so my axis of symmetry is 2. I plug in 2 squared minus 4 times 2 plus 6, so that gets my vertex of 2, 2. If I plug in 0 for the y-intercept, 0 minus 4 times 0 plus 6, my intercept is 0, 6. To find the roots, I have to graph it. So 2, 2 is my vertex. If I plug in 0, I get 6. If I plug in 1, I get 3. If I plug in 3, I get 3. And if I plug in 4, I get 6. So graph that at 0, 6. 1, 3, 2, 2, 3, 3, and 4, 6. So my parabola is up here, so my solution is, there is no solution. Empty set. All right, this one is in vertex form, so my axis of symmetry is right here, so x equals negative 2. My vertex, is plus 0 out here, so my vertex is negative 2, 0. If I plug in 0 for my y-intercept, I get 0, negative 4. I will make my table, so I'll put my vertex in the center. And if I plug in negative 4, I get negative 4. If I plug in negative 3, I get negative 1. I plug in negative 1, I get negative 1, and 0, negative 4. So if I graph those at negative 4, negative 4, negative 3, negative 1, negative 2, 0, negative 1, negative 1, and 0, negative 4, you can see that my parabola is hitting the x-axis, so my root is just 2. All right, an art gallery has walls that are sculptured with arches that can be represented by the following quadratic function where x is in feet. The wall space under each arch is to be painted a different color from the arch itself. So we're going to graph the function, determine the roots, and then we want to know how long is this between each one. So the first thing I'm going to do is find my axis of symmetry, of course. So negative b over 2a. So that is negative 4 over 2 times negative 1. So my axis of symmetry is negative 2. Plug that in. So negative 2 squared minus 4 times negative 2 plus 12. That gets me 16. So my vertex is negative 2, 16. My y-intercept, I plug in zeros, and I get 0, 12. I'm going to make a table. So put my vertex in the middle. So negative 2, 16. Plug in negative 6, I get 0. Plug in negative 4, I get 12. Plug in 0, I get 12. And 2, I get 0. I'm going to graph those at negative 6, 0. Negative 4, 12. Negative 2, 16. 0, 12. And 2, 0. So there's my parabola. So my roots are negative 6 and 2, but the question says what is the distance between these two? So my distance from negative 6 to 2 is 8 feet. All right, the x-intercepts are also called the roots or the zeros. When the vertex is above the x-intercept, the solution is there is no solution. If it doesn't cross the x-axis, there is no solution.